All right, let's fill in these three words. We will be studying basic trigonometry with these three words. Let's fill this in real quick. Trig ratios. So you really only need two blanks there. Trig ratios is the words that go right here. Trig ratios. And we don't really need that third side. Okay, I'm going to see how this goes with me going back and forth between the two. Okay, so in order for us to figure out some trig ratios, we are going to watch this quick video. And we're going to pause it at different points, okay? Now, this is a video from high school students in a high school in Ohio. All right, so it is cheesy, as you would expect. High school students making a math video. Okay, so just humor me here for a minute. You can't really hear it. It's like my students. Okay, so we know that. Side opposite the angle is called the opposite. We'll fill this in a minute on our notes. Okay, so let's go back to our notes. So they talked about different things on the side. So let's look at our diagram that we have in our notes. The hypotenuse side is which one? C, right? Okay, I would agree with you that C is going to be my hypotenuse. The side that is opposite of angle A. Okay, so angle A is here. What's the side that's opposite? Little a. Please make sure you're using lowercase and uppercase because they mean different things, okay? So then what is across from or opposite of angle B? Lowercase b, okay? Adjacent. This is a new word for us, kind of. What does adjacent mean if you think about adjacent angles? Next to, right? So we're going to have sides that are next to. So let's talk about this really quickly. This is where adjacent, this is the most confusing part for students. If I'm talking about angle A, I already know that C is the hypotenuse. I know that A is the opposite. So what's the only side that's left here? B. And B has to be the side that is adjacent to angle A. Now again, if I were to look at angle B, C is the hypotenuse. B is opposite, so which one has to be adjacent? A, little a. Okay, so the trig ratios that we're going to be studying are called sine, cosine, and tangent. So let's write these words out, and then we're going to talk about what is the shortcut? So sine, S-I-N-E. It is abbreviated with just S-I-N. So if you guys look on your calculators, you have that sin button. We will be not calling it sin, we will be calling it sine, because that's what it really stands for. Next to it, you have cosine. But on your calculator, it's what? Just COS, cos, right? Cosine. But when we are talking about it, we're going to say cosine. Okay, we're not going to say the abbreviation, we're just going to write it. And then we have tangent. That we abbreviate tan. Okay, so it says we're going to continue to watch our little video. Okay, again, humor me. And we're going to learn out what sine, cosine, and tangent really mean. I mean, you really wish you were doing this instead of math class, right? Making a music video. No? So we're going to use this. You don't have to write anything down yet. Okay, so we learned the different, they kind of talked a little bit about the different ways that you can find the sides. Okay, so that SOHCAHTOA thing, I want you to write down the edge of your paper. All right, so SOHCAHTOA, write down the edge of your paper. Let me move my screen down. So I'm going to write SOHCAHTOA. And this really is going to help you, I promise. SOHCAHTOA. And I would like you to write it long ways like that, vertical. Okay, if we are going to deal with the sine function, okay, we're going to use the letters O and H. So next to the S, let's put sine. Sine is represented by the opposite side over the hypotenuse side. This is why we write it vertically, so you know which one goes over which. Sine is the opposite over hypotenuse. So over here on the middle of the paper where it says find the sine of A, well, we know sine is opposite over hypotenuse. So let's look at angle A because that's the one they tell me to look at. What's the easiest side to recognize, would you guys say? Hypotenuse, right? Every time the hypotenuse is going to be the easiest one for us to recognize. So let's go ahead and label for this example. This is my hypotenuse, and then sine requires that I also find the opposite. So which side is opposite of angle A? 4, right? So this is my opposite. So my fraction over here says right opposite over hypotenuse. So 4/5 is going to be the sine ratio of angle A. Now if we wanted to find the sine ratio of B, angle B, okay, so now I'm switching angles. I'm going down to where B is. Again, I need the opposite and the hypotenuse, and the easiest one to identify is always your hypotenuse. So which side is opposite of B? 3. Would you guys agree with Tish? Okay, so now this ratio, opposite over hypotenuse, is going to be 3/5. So it changes based upon the angle you're looking at. All right, so we figured out the sine of both of those. Let's talk about cosine. So back over here, cosine is represented by adjacent over hypotenuse. Adjacent over hypotenuse. Okay, so let's look at the angle A. It says find the cosine of A. So if I'm looking at angle A, I need adjacent over hypotenuse. Well, the hypotenuse, again, is the easiest one to find, so let's do that one first. We know that it's 5. Now I have to decide between 3 and 4 which one is adjacent. Well, don't we know that 4 is across, right? So 4 is going to have to be the opposite, which means 3 is left as the adjacent. So for this example, for angle A, I want 3 over 5. So then if I say the cosine of B, I still want adjacent over hypotenuse, but now I'm going to switch the angle that I'm looking at. We're looking at angle B. We want adjacent over hypotenuse. Well, what's my hypotenuse again? 5, right? Which side has to be adjacent? 3 or 4? 4. Good. So my cosine of B is 4 over 5. So again, your sides are going to change. Your opposite and adjacent sides are going to change based on the angle that you have. Okay? Hypotenuse will always be the same spot. So what do you think TOA stands for then? So we have our tangent. Opposite over adjacent. Good. So if I'm looking at my example here, if I have opposite over adjacent, talking about angle A, 4 is the opposite because it's across from it, and 3 is going to be my adjacent. So what's my fraction going to be, Dakota? 4 over 3. Good. Same thing for the tangent of angle B, opposite over adjacent. So if I'm looking at angle B, opposite and adjacent. So Adela, what's this fraction going to be? 3 over 4. Good. Does anyone have any questions about that first triangle? Okay, I'd like for you to do this example, the second example for triangle XYZ. Do the exact same thing that we just did. I'll give you about 3 minutes to work through them. Guys, it is helpful. I need you to look up here for just a second. It is helpful to do this part that I just highlighted. That's extremely helpful until you get into the hang of knowing which one is which. Okay, so for this example XYZ, I want you to put the O over H, the O over A, whatever it is, until we become experts at this, please. Does anyone else need a calculator while Dakota's up? Because you're going to need one. Not just your phone either. What number are you?
5.
What number are you? No, you're not good. You need your calculator for this. What number is your book? What book number are you?
6.
6. Ooh, give him one. Give him number 1, Dakota. Not that little one. I don't want to use the little one. Victoria, you can use that one for this. That one is okay if you want to. It has the same thing.
I don't have the same.
You do. Let me see it. Oh, you don't. Wait, yeah. You can use this one if you want. Sorry, Amanda. I didn't notice you didn't have one. I'm sorry. You don't need your calculators yet. You just need to find your ratios. You don't need your calculator yet, Victoria. Okay, about 1 more minute, and then I'm going to call on you to help me fill these in. All right, Chelsea, what'd you get for sine of x? Is it 12 over 13? Should be confident. What is it? Perfect, 12 over 13. Excellent. Okay, what is the cosine of x, Austin?
5 over 13.
5 over 13. Excellent. Tish, what is the tangent of x? 12 over 5. Who got all three of those right? 12 over 13? 5 over 13? Okay, Patrick, what is the sine of z? 5 over 13. Excellent. Elena, what is the cosine of z? 12 over 13. Victoria, what is the tangent of z? Perfect. 5 over 12. Awesome. How do you guys feel about that? Doing okay with that part? Okay. I won't bore you with the video anymore. How about that? Since you guys seem like you love it so much. Okay. Using a calculator. You will rarely do this next part, but we're going to do it just so you can practice it. Using a calculator. With your calculator, the first thing you need to do with a graphing calculator is hit the word mode. Everyone hit mode on your graphing calculator. Underneath mode, the third line says radian and degree. Do you guys see that? It should be blacked out on degree. If it's blacked out on radian, you need to fix it. So if it's on radian, you need to arrow down and then arrow over to degree and hit enter. Okay, so that it's in degree. Now, to go back to your home screen, you're always going to hit second and then the quit button, which is right beside it. Second quit should take you back to your home screen. Okay, now, in your calculator, I want you just to type in sine of 39. Okay, sine of 39. Now, not sine, don't hit this one. Just sine. 39. When you are doing this, we need to practice rounding because some of us struggle with rounding. What did you guys get when you got sine of 39? 0.62932, right? 0.629. I'm just going to write this down here so you can see it. 0.62932. They are going to ask you most of the time to round to the 10,000th place. 10,000ths is how many decimal places? 4. That's 4 decimal places. So if I'm rounding this to 4 decimal places, that means it cuts off right here. Is the 2 big enough to change the 3? No. What if this was a 9 right here? Would I still change the 3? No. You only look at the number that is here. So because the 2 is not big enough to change the 3, remember it has to be 5 or bigger to change it. My answer here is going to just be 0.6293. That's it. Please put a 0 in front with a decimal. All right, now go on and do cosine of 58. What is cosine of 58? Go ahead and do the other three. So for cosine of 58, you should have 0.1192. Oops. Tangent of 85. 0.177, I'm sorry, 0.178. Oh, well, let me change mine then to make sure it's degree. Oh, it's not. That would be the problem. So let's try this again. So if I do tangent of 85. Oh, is that better? 11.4300. Okay, but is this big enough to change it to a 1? Yes, so it should be 11.4301. Okay, and then what did you get on sine of 30? Just 0.5, right? There's nothing else that comes after it, and so because there's nothing else that comes after it, you can put just 0.5. Okay?
And can you do cos 58?
Cosine, oh, because I changed it. Yeah. What do you guys get for cosine of 58? 0.529. 5.99. Okay, so 0.5299 is what I'm looking for there. Because if we're rounding 4 decimal places. Okay. All right, let's do some real life examples, shall we? Flip that over on the other page. Okay, there are going to be 2 things you're doing when you use the trig functions. You're either going to be solving for the opposite side, or you're going to be solving for an angle. I'm sorry, not necessarily opposite. You're going to either solve for an angle or for a side. So if we look at this example, the first one, where is our variable? Is it a side or is it an angle? It's a side, right? So which one of the SOHCAHTOA are you supposed to be using? How did you know that? Okay, so here's the steps. This is how you know which one you're supposed to be using, because this is the most confusing part for students. How do you know which one to use? Number 1, look at the angle. And number 2, what is given to you based on the angle? So you're going to look at the angle, and then you're going to look at what has been given to you according to that angle. Let's go ahead and write our SOHCAHTOA down the side. Okay, in this example, we're talking about angle that is 38 degrees. So I'm talking about this angle here. What have I been given? For sure, I've been given, what is 10? For sure. The hypotenuse. So we're going to put an H there. This is how you label your picture. Okay? Then we have to decide, is X either the opposite or is it the adjacent? Is it all the way across from 38? Because that would be the opposite. It is the adjacent. You've been given adjacent and hypotenuse. And so if you look over at your SOHCAHTOA, which one is adjacent and hypotenuse? Cosine. You guys see that? adjacent and hypotenuse over here means that I'm going to be using cosine. So I want you to follow these steps. Please don't skip anything. Cosine of the angle equals adjacent over hypotenuse. We are setting ourselves up. Cosine of the angle equals adjacent over hypotenuse. Now I can fill in with what I know. My angle is 38, so I can say that cosine of 38 equals adjacent over hypotenuse. X over 10. Is everyone okay with where that came from? Questions on where we got that? Okay, now if I want to solve this for x, what do I need to get rid of? We need to get rid of the 10. It's already being divided, so what do I have to do to get rid of division? Multiplication. So I'm going to multiply this side by 10, and it cancels. And I'm going to multiply this side by 10. In your calculator, okay, in your calculator, you should have 10 times cosine of 38. Close your parenthesis, please. Look at my calculator, that's how yours should look. 10 times the cosine of 38. And then your enter button is your equal sign. We're getting 7.88. Now for these examples, I want us to round to the nearest tenth, as it says in the directions, round to the nearest tenth. So that's 1 decimal place. So if it's only 1 decimal place, that means I'm rounding it here. 7.88, which means it should be what? Good, 7.9. Okay, so you're going to say x equals 7.9. Okay, let's try the next example to the right. This one over here. Okay, so the first thing to do is identify our angle. Which two pieces have we been given? What is y? I have to go across, right? I know that this over here is my hypotenuse. That's the easiest to identify, and I would do that almost every time. Okay? So across from 85 is my y, and so if I have to go across, that's my opposite. Which means 12 has to be the adjacent. So I've been given opposite and adjacent. And which of your trig functions is opposite and adjacent? Do you guys agree with Dakota or no? Opposite and adjacent is your tangent. So remember, you're going to do tangent of the angle equals opposite over adjacent. Setting yourself up. If you choose to skip this step, I have zero sympathy for you when you come to me and say, I did this all wrong. And I'm going to say, why didn't you set it up? Well, I was trying to take a shortcut. Well, unfortunately, that's not going to work here. So we have tangent of 85 equals opposite over adjacent. And then how do we get rid of? Good. We're going to multiply each side by 12. And then in your calculator, 12 times tangent 85. And we're rounding to the nearest tenth. Are you getting 137.2? Good. That means that that side is the side where y is 137.2 whatever inches, feet, whatever. Okay? All right. Let's try to set up this one down here, and I'll move my board up a little bit. Okay, try to set up the angle with 70, the triangle with 70. Find your angle first. Identify your hypotenuse. That one's the easiest to identify. If I have to go across, that's my opposite. So I have opposite and hypotenuse. Mackenzie, which trig function am I going to use if I have opposite and hypotenuse? Good, sine. Excellent. Okay, so I know that sine of the angle equals opposite over hypotenuse. Again, if you are choosing to skip this step, you are setting yourself up for failure. So sine of 70 equals 34 over z. Sine of 70 equals 34 over z. Okay. So interesting now, our variable is in the denominator, and we haven't had our variable in the denominator yet. So what do I need to do to get my variable out of there? What's the steps we need to take? Anybody know? I can't divide. Multiply what? Okay, so we got to get z out of the bottom. So Chelsea says let's multiply z on each side. So I get z times the sine of 70 equals 34. Okay, I can't plug that into my calculator. Go ahead and write this down. I can't plug that into my calculator because I don't know what z is. How would we get z by itself? How would we get z by itself? If we divide by z, then we're going to put z on the other side, and it's still going to be in the denominator. What do we need to get rid of that's next to z? The sine of 70. And if it's being multiplied, I need to do what? Divide by sine of 70. I'm going to teach you a shortcut in just a minute, so just write this down with me. So I get z equals 34 over sine of 70. Now before you go to your calculator, I want to show you something. Do you see that right here up at this step, if I had just switched these two out, if I had switched positions up here, I would get down here at this answer? Do you guys see that? If I had just switched the z and the sine 70, I would get down here, right? Because they really just switched positions, and I wouldn't have had to do all this. So here's the trick. When your variable is in the denominator up here, when your variable is in the denominator, you can just switch them. And this is the math reason why. Okay? But you don't have to show me this work every time. You can just switch them when the variable's in the bottom. So now with our calculator, you need to, in your calculator, put 34 divided by sine, and it will pop up a parenthesis automatically, 70, close your parenthesis. (34) divided by sine of 70. I have 36.2. What do you guys have? 36.2. Okay. So z equals 36.2. So it depends on where your variable is, whether or not you're going to do the switcheroo. So why don't you try the next example on your own? Try the next example on your own. Follow our steps. Find the angle. Bless you. Bless you. Bless you. So we all should be using sine ratio. If you and your neighbor are using opposite or different ratios, like one of you is using sine and one of you is using cosine, you're doing something wrong. Okay, one of you is doing something wrong. There's not whichever one you choose. It's which one has been given to you. So the sine of the angle is opposite over hypotenuse. So sine of 50 equals 45 over a. We did the old switcheroo because my a was in the denominator. And when I divide 45 by sine of 50, what do I get, Aaliyah? 58.7. Anybody agree with Aaliyah? I do. Any questions about that? You guys feeling okay? Okay. So now we know how to solve for a side. And now we're going to solve for an angle, which is basically the same thing, except we have to use what are called inverse functions, and I'll show you that in just a minute. So what I'd like us to do on this next example is to go ahead and get your diagram set up. Again, find the angle. This time the angle is the variable. Find the angle, and then figure out which trig ratio you should be using. Here's my angle. So if I go across, my opposite, and this is my hypotenuse. So again, we're using what? Sine. So if I have sine of the angle equals opposite over hypotenuse, so we should have sine of x equals 7 over 20. Now, previously my variable has always been in the fraction part, right? The variable is either in the numerator or the denominator. When your variable is next to the sine, we have to kind of undo that sine function. And the way we quote-unquote undo that sine function is to do what we call the sine inverse. So I'm going to put this side in parentheses, and I'm going to do sine to the -1 power. Sine to the -1 is really sine inverse, which means it undoes what sine has already done. So whatever you do on one side, you have to do on the other side. So on your calculator, okay, when I hit my calculator, that drawing is going to go away. So I want to show you on your calculator. You're going to hit second sine. Why are we hitting second sine? Okay, because if it's in blue, then you have to hit the blue key first. Second sine gives you the blue key. All right, and now we're going to do 7 divided by 20. Close your parenthesis. That's how it should look in your calculator. the sine -1, which means sine inverse of 7 over 20, is 20.48. So if I want you to round it to the nearest tenth, that's what? 20.5. Good. So our x value is 20.5. Okay, let's go down and do the one right below it. Go ahead and do the one right below it. Again, we're going to find our angle. This is my hypotenuse over here. I know that's not what I have. 18 is which side? Good, opposite, which means 21 is adjacent. So if I know opposite and adjacent, Austin, which trig function am I going to use? If I know opposite and adjacent, what are we going to use? Good. Okay. So tangent of the angle equals opposite over adjacent. I don't know my angle, I just know that it's y. (18/21). Remember, the rule is when your variable is next to the tangent or next to the trig function, we always have to do the inverse. So if I had sine and I did sine inverse, now I have tangent, so I'm going to do what? Tangent inverse. And I need you to show your work. This is showing your work. You're telling me you know that you need to use the tangent inverse. So you put the thing in parentheses, write your tan -1. That's an exponent, by the way, and it means inverse. And we'll talk about that in Algebra 2 more. So in my calculator, I need to do second tangent. Second tangent, 18 divided by 21. Whoops, that's not what I had. $40.60. Is that what you guys have? Okay, so 40.6 equals my y value. All right, go up to angle W. Here's my angle. So we have been given adjacent and hypotenuse. Amanda, which trig function are we going to use if we've been given adjacent and hypotenuse?
Cosine.
Good, cosine. Tish, how are we going to get W by itself? Okay, what's that called? Power of -1 is called the what? Inverse. There we go. Okay, so we're going to use cosine inverse on each side. Cancels that out over there. Cosine inverse of 15/27. Elena, what are you getting?
56.3.
56.3. Does anyone agree with that?
Yes.
56.3. Got to make sure that you do cosine inverse in your calculator. Remember, these are representing our angles, so we should be putting the degree mark. Right? These are representing our angles, so on these bottom 4 examples, we should be putting our degree symbol because they're representing the angle measurements. All right, try that last one. So we should be applying inverse tangent of 12 over 32. Victoria, what did you get for z? What did you say? 20.6. Does anyone agree with that?
Yes.
20.6 degrees. Excellent. Okay, how do you feel? You're okay? All right.